Hello everyone, and welcome to the final part of my open mock paper review. This paper is a little bit too hard. If we are comparing it to last year, it is definitely too hard. If you're comparing it to previous years, there have been very difficult papers as well. However, I know myself that as a whole, when I set papers, I go for educational value and interest as much as realism. So again, with all apologies for typos aside, I do want the paper to expose you to as many new ideas as I can. And I want it to be such that even someone who has actually done every past paper from the year 2000 until now will still find it interesting. The SMO is not prepared by one person. It is prepared by a team made up of course, the final selectors, but also questions are proposed by teachers and interested members of the mathematical community, which gets combined to the final paper. And therefore, sometimes the final result doesn't really have a specific purpose, and you may have an overload of a particular topic, or you may have maybe a bit less exciting features. I've tried to make the paper interesting, but that also means that it is on the difficult side. So as some of you have asked, I think I have said that, yeah, I mean, the cutoff for a paper like this would be somewhere in the 12 to 13 range, most probably. It is difficult, although of course, I think that there exist 10 questions that are doable, like with normal tools. And also, as we saw in the last video, somewhere it is difficult to prove, but it is not difficult to semi-guess or reason it out. Yeah, of course, when I say cutoff, we know that means the round 2 cutoff, so you can kind of estimate your silver as 2 points below that, and same for your bronze and HM. This is an estimate, which is even sometimes I can't remember what I wrote in my previous comment, because depending on what I just said, sometimes I round it up by 1 or round it down by 1. And also the fact is that yeah, due to the typos that I've made, that can affect your score by 1. And that's also true of the SMO, with like sometimes we are not sure whether for a question where they made a typo, did they void the question, did they give everyone 1 mark, did they not give anyone a mark, did they just make it out 24? These they do not review. So always take this with a plus minus 1 kind of margin of error. I have said that the SMO is often a little bit less novel. I mean that for those of us who have done way too much practice, or as a teacher, I've talked through way too many problems. Please don't take this as if you are new to Olympiad, something is wrong with you. No, the questions are very interesting the first time. Just that if you have done Olympiads for a while, then more and more of it will look familiar. So it rewards practice. Please practice well for the SMO. It's just that I would prefer that the SMO is a little bit more resistant to just pure practice. Right? That's just my personal take. Now, getting to the questions proper, question 20, first of all, this is my idea of a slightly more unusual complex number question. If you are looking at the set of complex numbers, this is effectively using an Argand diagram. It's that root 2 over 2 to root 3 over 2 is a vertical strip, which I won't draw yet because I want to draw something else. Right? Determine the minimum the positive integer k such that for all positive integers n greater than or equals to k, there exists a root of z to the n equals to 1 in S, that vertical strip. In other words, there exists an nth root of unity. Now, I want to draw the unit circle first, because roots of unity lie on the unit circle, and also root 2 over 2 and root 3 over 2 lie at significant places on the unit circle, right? We know that root 2 over 2 will be at the 45-degree mark. And root 3 over 2 is going to be at the 60-degree mark, or 30-degree mark, depending where you're looking from. So if you were to put it like this, this is the 30-degree mark. And this region is S. Now, this simply means that you need to make sure that there is an nth root of unity, and I'll just work in degrees here because I already wrote like these in degrees. This is 45 degrees, this is 30 degrees. Your n roots of unity are at 360 degrees over n. And then of course multiplied by m, where m goes from 0 to n minus 1. This is how your positions are of the roots of unity around the circle. Therefore, I need to look for all the, well, how do I put this? I need to look for the value that is big enough such that your roots of unity are close enough that there is definitely going to be one between the 30 and 45 degree mark. I don't have to worry about the conjugates below because your roots of unity come in conjugate pairs anyway. So how am I going to do this? Well, I'm going to just put this directly into an inequality so that I can cancel off the degrees and just look at what does it actually tell me. Remember, I want it to be that m exists, not that it is true for all m, obviously. Okay, so if I were to divide by 360, and if I reciprocal it, n over m is between 8 and 12. Or if you like, 8m is less than or equals to n, less than or equals to 12m. Now, simply put, this means that if you're looking for n's that work, m equals to 1 gives you 8 to 12 works. M equals to 2 gives you 16 to 24 works. M equals to 3 then gives you 24 to 36 works. And you can see that the gap has closed. Therefore, for any further n beyond the mark of 16, there will exist an m such that a root of unity in that interval exists. Therefore, your k is 16. Take note that it is not enough to just say that, I look for 15 degrees. 15 degrees is 1/24th of 360 degrees, so therefore k is 24. We can say that 24 and beyond definitely work, but that doesn't mean that it can't work before that, right? So we still need to do the actual checking in a form that is something similar to this. Okay, question 21. Now, this is an idea taken from some old AIME problem. A, B, C, D, F are non-negative real numbers which sum to 1. You have got a condition on A, C, and B, D, F, and you want the maximum possible value of A, B, C, B, C, D, and so on for all of these. I can tell that there is some algebraic identity that I don't yet know, because no one knows identities on combinations of 3 out of 6 variables, right? But we suspect there is something. When it comes to discovering algebraic identities, there's a little bit of a matter to it, which is that you want to look for any interesting combinations that appear or don't appear. I would also look at signs and coefficients normally, but here everything is plus and there's no coefficient, so I have to actually look at the variables. And I will notice that ACE, BDF, ABC, BCD, all of these. If I pay attention, A and D, B and E, and C and F don't ever appear in the same term. And so therefore, this motivates the fact that actually they appear in the same bracket, and this is the expansion. This is the expansion that is going to give you all this stuff. There are 8 terms. Right? ACE and BDF are here, and then the rest of them you can sort of just say it goes in a loop, right? ABC, BCD, CDE, DEF, EFA, FAB. So all of them are there. And now you just use AMGF, because if you want to get the maximum possible value of this thing, you want the maximum possible value of this. And the maximum possible value of this by AMGM is just going to be 1/3 cubed, right? When these 3 are all equal, since the 3 bracketed things sum to 1. And so therefore, you just get 1/27 minus 2/2025. So that will give you 73/2025. Answer is 2098. But hang on, do I need to check equality can hold? Well, actually, that's not too hard to do, because is it possible for these all to be 1/3? Of course. Is it possible for all these to be 1/3 and for this equality to hold? I don't see why not. Right? Because it is entirely possible just to let, for example, A be 0 and 1/3, so that will kill off this term, and then you just pick your E and F accordingly to make 2/2025 happen. So this is very easy to attain equality. Therefore, I'm not going to work out the exact value since that's not necessary. 22. This is actually not difficult, but it is more of a meta question, because a lot of times you have seen this problem type and we know how they work, because how it normally works is that I see x and 1 minus x, I just swap them by, well, if I have got this here, this is the original one, I'm just writing it again. Replace x by 1 minus x. So then, what would you do? You would normally say that fx and f1 minus x are 2 unknowns. I am effectively just going to treat it as a pair of simultaneous equations. And how will you treat it as a pair of simultaneous equations? Just eliminate something. Right, so for example, I can take 1 minus x squared times of 2, and that will eliminate fx. But since I don't want to write f1 minus x, I think that will be confusing. I'll just eliminate f1 minus x instead. So 1 minus x squared times the first equation minus the second equation. And that would give me 1 minus x squared minus 1 equals to some stuff. I say some stuff because, or rather this times of fx equals to some stuff. Well, I know that I would then be able to find fx unless I'm not allowed to divide. And so therefore, the actual thing is that it can be determined for all values of x. I don't have to care what's on the other side. I have to care about when it cannot be determined, which is that 1 minus x squared equals to 1. That would be when x equals to a and b, this is true. So I can now just, well, this is squares, so I can say that this equals to plus or minus 1. And I know that x squared minus x plus 1 equals to 0 has no real roots. So I can just go to x squared minus x minus 1 equals to 0. And just for coup de grace, let's just use Vietas to finish off. So it's a bit of a meta question, because we have done this task many times before where I ask you, okay, please find f of 2025, please find f of 10. So now I decided, okay, let's find out when we cannot find it out, and hence you ended up with this equation here instead. Of course, in order for me to make sure the question works, I did need to check that the function actually makes sense, and so I did, but you don't have to check that. Okay. Question 23. This is the calculus question. It is a calculus question which is not easy actually, but again a little bit more unusual than if it were just please calculate this derivative, integral, or limit. This was adapted from an idea from Stanford Math Tournament, I think, from some years ago. In order to do this, what you actually would like to understand is that you are choosing C to give you the minimum. Think of it as actually this is the gap between x squared plus 21x and C. And you are integrating it. And so if let's say that I have x squared plus 21x, I know that x squared plus 21x just increases from 0 because the vertex is at the negative. So it is just going to be something like that. If you pick, let's say, C to be here, then it's going to be this area. That's what the integral is going to calculate. And if let's say that you pick somewhere down here, then of course the area is this. So we have to take an intuitive approach again to this and say that, oh, that means that if I want the area to be minimized, every time when I slide this line down, it's almost as it were thinking along the first derivative test vibes, right? When you make a tiny shift, how does it affect things? Well, it affects it by this small rectangle and this small rectangle, but the small rectangle below is bigger, so therefore I should shift it down to here, because that is still going to have a reduction. And then likewise, you can continue shifting it down as long as this rectangle versus this rectangle, the rectangle below is larger. And you stop when they are equal. What does that mean? That basically means that you just stop halfway, but by halfway it means halfway across the x. Because this tiny rectangle here and this tiny rectangle should have the same length. Now, once you understand that, it's just a computational exercise for your integration. I will just write it in this way, right? Because this is f of 15 over 2. Sorry. So it's actually just going to be up to 15 over 2. It will look like this. And then after that, beyond 15 over 2, it will be the other way. you can then just observe that the f15/2 gets cancelled off, essentially. Because both of these intervals are of the same length. And so if I take the antiderivative, the first part is negated, and then the second part is not negated. So this will be your actual value, and then you just need to substitute that in. This is a little bit annoying again, and so therefore I put in a bit of effort to ensure that the correct value is 2025, so that once you got it, then you have a bit of a laugh and you know that it is correct. Obviously, this is also sort of a message that I have to send, which is that yes, you can guess the year number, but out of all the questions in this paper, is this really the one that you thought 2025 is going to come out from? No. So it is not going to be the ones where you see 2025 spammed everywhere that turned out to give you the value of the year. There are many ways that we can sneak them in a surprising fashion. Okay, 24. This is a recursive sequence that sounds scary, but is actually not so bad. Now, what has happened here is that your sequence is obtained by essentially iterating a function. Right? So it's sort of like if this is 1 and this is 1/3, 2/3, 1, your function is such that I want them to keep on going back to 0 again. Which is another way of saying that this is actually just the fractional part of 3an. Yeah, because the -1 minus 2, all this correspond to the floor. So it's essentially the fractional part, just expressed in full. What is the fractional part? Well, normally the fractional part of a number is you take the decimal. And so for those of you who actually have done some coding, you may have done some bit manipulations which are in binary, in which case you may recognize that doing something like this is actually sort of base 3 just left shifts. What do I mean by that? Well, clearly your A0 is between 0 and 1 means you could write it as a decimal. So let's say that A0 is the decimal just in base 3. I put ... If it's a terminating decimal, that just means that those decimal places are 0. That's okay. Now in base 3, if it looks like this and you multiply by 3, it just shifts it by one step, right? This is how, just like multiplying by 10 in base 10 or multiplying by 2 in binary works. And if you were to now take the fractional part, that has the effect of just, as I said, shift it to the left, and then you're just truncating it, effectively just deleting something off. So that's what this function does. This function is essentially, if you write it in base 3, you are sliding it one step, and if I want the sequence to have a period of 7, that is the same as the decimal has a period of 7. If the decimal has a period of 7, then it just means that there are 7 choices for the first 7 decimal places, except that they can't all be the same, because if they're all the same, that period would just be 1. So you can't have 0.1111, that doesn't have period 7, that's period 1. So the 3 cases you're subtracting is just a bunch of zeros, a bunch of ones, and a bunch of 2s, which are technically going to correspond to 0 and 1 and half in base 3. I know that looks a bit weird, right? But you will see that's what it means. And if you put in 0, half, and 1, you will see that that's actually where you're going to get your period length 1. Okay, so that has to be thrown out, and you're left with 2184 as the number of values of A0. At some point, right, whether that point was in here, or that point is here, or that point is here, you're going to say that, oh, come on, how am I supposed to think of all of this? You may not. Don't feel lousy, but also don't get the wrong understanding. An Olympiad is not supposed to be uncorrelated to effort, but it is not supposed to be perfectly correlated with effort. There are just some days where you figure out the idea. It's like solving riddles. Nobody can possibly solve every riddle. But the more math we do, the more we will encounter these ideas. And also, when you do a practice paper especially, just take it as, oh, now I've learned something. Okay? Don't think of it as, how would I think of that it comes out in the competition? Well, if this comes out in the competition, now you know. That's a good thing. But be prepared that if such a thing happens where you have not seen it before and you just feel that this is impossible, just keep it. It's okay. Finally, and this really has a note of finality because my gosh, this looks very long. I'm just scaring you, it's not that long. 100 term sequences where it is strictly increasing with the exception of a pile of zeros everywhere. Meaning that if you remove the zeros, it's okay if there's nothing. It's okay if there's a 1. It's okay if, let's say, there is this 3 numbers. It is not okay if it is 1, 1, because that's not strictly increasing. That's just non-decreasing. This is actually quite simple if you don't panic. Why? You start by noting that there are 100 term sequences, therefore you're not going to run out of numbers to put. So it's just actually, how many zeros do you put? So suppose there are m zeros. There are 100 choose m ways to place zeros. And then there are 25 numbers excluding 0, where you will pick 100 minus m of them, and you must put them in increasing order. That's all. And so therefore, your n is just this times this, summed from 0, you can have no zeros, to 100, they can be all zeros. This is a special case of your Vandermonde identity, which happens whenever you see that these two things sum up to a fixed number and you have got two constants on top. Essentially, you can think of it as you have got 100 objects of type A, 25 objects of type B, and this will tell you the number of ways to pick 100 out of the two groups in total, depending on how many you picked in front, which I realized my summation variable is m, not I. Therefore, this is just 2125 choose 100. The reason why I have to ask for one more layer is just that, unfortunately for us, there is no actual unique representation, right? So if 2125 choose 100, it's also 2125 choose 2025. It may also be equal to some other choose thing. So I can't be sure of that, and therefore I have to get an answer extraction from you, which is via this 17 to the power of k. That's not too bad, however. It is not too bad because you just count 17s. Okay, so for 100 over 17, you round down, you just get 5. 2025, you divide by 17, you get 119. And then after that, plus 7. 119 divided by 17 is 7. 2125, you divide by 17, you get pretty nicely 125. And then 125 divided by 17 is 7. And so therefore, yeah. 132 minus 126 minus 5 is just equal to 1. That's counting 17s, which is just an answer extraction that I wanted to pick that no one's really going to guess 1. So this is as neutral as I could come up with. Okay, and so that's the end of this paper. It is, as I have mentioned, not an easy paper. Some of you, of course, may have submitted a bit earlier when I hadn't yet corrected the typos and the answering form. So if you want to go and check your score again, of course, you can go and submit it to the form again and check your score again. But I hope you found the paper useful. Feel free to leave any comments below on the general difficulty, on any questions you liked, on any other general thoughts. And if this is the last video you watch before the SMO, then all the best. I'll see you in the live stream after the SMO round 1 itself. Okay, so bye bye and see you soon.